Well, this terminology of internal combustion engine, if somebody said change it up a little bit, you'd say, oh, how about external combustion engine? And that's what they used to have. And here's an illustration found out there on the internet of where they used to have a steam engine, and they would burn the coal somewhere external to where the steam expands. So where the steam expands and you're getting work out in here, that's called external. External combustion to where the piston's being pushed back. Internal means that that's where the combustion's occurring and it's pushing against, right intimate with the combustion is you're pushing back the face of the piston or the top of the piston. So that's hopefully trying to explain that term. I understand combustion engine, you're burning some fuel, but why internal versus external? There you go. Reciprocating, these are one of these great things. I still remember when I was very young and I finally figured out, wow, that's how an engine works. So the piston's sliding up and down, it's reciprocating in a cylinder. I don't know if you remember any joy like that. It's like, wow, this is so neat, you know? And you look back at it and say, well, okay. But, you know, I still remember being very excited figuring this out. So the cylinder is stationary and the piston slides up and down. It's reciprocating, going back and forth. And you get out of it the rotary motion, rotational motion of the crankshaft. And there it is, the beauty of the crankshaft. That offset that makes it go around. Right? So, but we're going to study this reciprocating motion, the piston going up and down, and then we'll leave it to your other classes, mechanisms and other things about translation and rotational, from translational motion to rotational motion. But one of the things that you'll look at is we'll talk about looking at this way on the crankshaft. And we start with a connecting rod, and the connecting rod rotates 1/2 a rotation. When it rotates 1/2 a rotation, it brings the piston from the top down to the bottom. See that? The piston now goes from top to bottom. So we'll talk about, the piston's at top dead center. And now, okay, 1/2 a crank, 1/2 a rotation, it's now at bottom dead center. See that? So maybe I'll draw it again. This length is the same right here. So I'm not going to try and change that length, but I'm going to try and put it over here. And now the piston's here. So the piston went from top dead center to bottom dead center with a rotation of 1/2 a rotation of the crank. If you do another 1/2, the piston goes back from bottom to top. So one complete rotation gives you how many slides or strokes of the piston in the cylinder. One stroke down and then one stroke up. So you got 2 strokes for one rotation. Then if you do another rotation, you get 2 more strokes. So you basically get 4 strokes. And what we'll find is we need 4 strokes to complete a cycle. So it's a 4-stroke engine or a 4-stroke cycle. 4-stroke cycle. You'll see that out there. Now, somebody says, I buy a weed eater, I'm using my weed eater, I have my gasoline, they tell me to add oil to it. And then I ask myself, hey, I know my car, I need to change the oil every now and then, pull the plug in the bottom of the oil pan and change the oil, change the air filter. I wonder where the oil pan is for my weed eater. Doesn't exist. Where's my oil filter for the weed eater? Doesn't exist. True? So there's something very different about your weed eater engine and your car engine. How many people own or ever been in a boat where you have an outboard motor or something and 10, 15, 20 horsepower? That engine, you mix a little oil with the gasoline, true, and then it runs. And then you ask yourself, hey, where is the oil pan for my outboard motor, my Yamaha, my, what is the big manufacturer of these outboard motors? Johnson, yeah, Johnson, some other ones, Where's the oil pan? I want to change my oil. It doesn't exist. Where's my oil filter? It doesn't exist. It's a 2-stroke cycle engine. Weed eaters, outboard motors on your boats and that are all two-stroke. And then your car, your diesel, they're all four-stroke. And right there is your translation, okay? You've got to go a stroke down, a stroke up, a stroke down, and a stroke up to complete a whole cycle, to redo it again. So you have to have 2 revs of the crank for one complete cycle on a 4-stroke cycle. You only need 1 rev for a 2-stroke cycle. But I don't really spend much time talking about it. It's another one of those marvels. It's like, how do you get it to work with 2 strokes? What is a 2-stroke cycle? And it's, if you know already, that's great. But you could take your weed eater apart before you throw it away. Strongly encourage. You only make it for so many hours. And you have big item trash pickup in your neighborhood. You see somebody else, your neighbor's throwing it away. Go over there, take it off his pile. Take it apart, figure it out, and before they come pick it up, throw it back on his pile. Your education's free, except for maybe a little embarrassment that your neighbor says, "What are you taking my trash off my pile for?" But really, take things apart. They're really helpful. Now, here's a typical engine, and they have a lot of names of parts, and you can be very confused. But as an aspiring mechanical engineer looking to graduate within a year, year and a half, you really don't want to say, what's that? Really, you should. I mean, a mechanical, this is our domain, true? Engines. So you should be able to, so take that engine apart off your neighbor's trash pile or your engine before you throw it away, and just learn how to call all the parts. And so I typically cover up the part names, and then I say, what is that? Okay, looks like what is that? Camshaft. And you have 2 of them, dual overhead cam engine. Hey, we've seen that. A lot of times they only have 1 cam. Here they have 2. What's this thing? Spark plug. And here's a way to get stuff in, and here's a way to get stuff out. That must be the intake and the valve controlling the intake, and this must be a valve controlling the exhaust. That's right. And those look like springs, valve springs. And then the cam rotates on a lobe and it pushes down. This is great. I still remember it. Wow, that's how it works. This is incredible. So as it's rotating, it's smooth here, and then it hits a lobe and it pushes down and makes that valve open, and then it goes back. That spring makes it go quickly to close when the lobe passes in rotation. In here is the combustion chamber, and they draw a little line separating here from here, and so everything above is like the head. You say, oh, got a cracked head or some problem with the head. Oh, just a head leak. Yeah, right. Never buy an engine that just has, just a little head leak. Yeah, it's a big job no matter what. And then below is the block. And in the block, they're even showing you, maybe this is some coolant passages for Gatorade-looking antifreeze. True, often it's green, sometimes it's yellow, but that's why I think they colored it that. And if you have a head gasket leak, oh boy, big job. Yeah. This is the piston, and it slides back and forth, and it's through this connecting rod. So that's a connecting rod. Down here is the crankshaft with a little bit of an offset between the center of the connecting rod and the center of the crankshaft. That offset determines how much stroke you get. This distance right here, you just say, hey, I think that's the distance that you're going to go. Two times the offset is the stroke. 2 times the offset, crank offset. Oil pan down here, whatever. Here are the names, but you can go and look up things on the internet. And I strongly encourage you to try to test yourself and quiz yourself as you're trying to learn material by covering things up and then repeating.
We're not going to go over any exotic engines.
No. Sure do not. Yep. Also, you can find great things out there on the internet about understanding the 4 strokes. So I like to put, and rotate, go intake, and then you have compression, then a power stroke, and then exhaust stroke. All of these you've been exposed to at Thermo 1, but take a look at them. Here is a little illustration that's out on the internet. And what I like about it is that I can open it up and I can run it. So if we hit start, or hit reset, okay? What they're doing is they have a piston and it's going to be starting to move. And as it moves, you can see the location on a pressure volume diagram, a little trace, that little dot, you can watch it. Let's hit start. And if it's supposed to, and so it's starting to come down. You could see it rotating with the crank, so you get that mechanism. Here's the volume is increasing, and then it hits the bottom dead center. Now the volume's decreasing, the pressure's going up, 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 so it's in the compression stroke. And then something happens, ZZ. Oop, look at that, it turns red, and the pressure skyrockets at constant volume. And now it's going down and expanding in the power stroke. The pressure's still high, and then you come down here and it rapidly drops. That's why you have mufflers. And there's a big blowdown. And then you pushing it out. This valve now kicked open. The exhaust valve is open. You're pushing it out. And then your valve closes. This intake valve opens. You're starting now again that intake stroke. Notice the pressure is low on the intake. It's a vacuum. It's a slight vacuum in the engine, right? If you have a vacuum leak, okay, you know, that's why. Air is getting where it shouldn't get into your engine. So you can trace this around. You see this is modeling a four-stroke cycle, like an Otto cycle gasoline engine. And you could just watch this a few times and you'll see, okay, I got the picture. A lot of exhaust goes down in the blowdown. Right now it'll be a big rush when that cracks open. Boom, right? Especially for engines under a load. You have a higher delta P right there. It's Mach 1. It's loud. That's why you have mufflers. And then it's above atmospheric pressure as it pushes it out through the exhaust manifold, catalytic converter, muffler, tailpipe, and then finally out. Yes? You're somewhere, anywhere. And so it'll just go until it hits a spark, and then you kicked it. But typically, if you're running, let's say, 2,000 revolutions per minute down the road, that's not very fast either. A lot of engines are going fast. You could find out it goes through a cycle pretty quick. It really goes through a cycle. And then you can do this. You're driving to Houston. Oh, let's see, my tach says I'm at 3,000 RPM. I'm going to be driving here for an hour and a half. I wonder how many times the piston goes up and down in my engine. And you just do some mental math, and you'll be amazed. I wonder how many times that spark plug is going to fire. Oh, I have 4 of them. Oh, I have 8 of them. You know, how many times does it fire between here and Houston driving for an hour or so? You'd be amazed. I put 100,000 miles on my vehicle. Should I change that spark plug? I wonder how many times it's fired. Change that oil? You got to change your engine now. Maybe the synthetics are getting that good. I know you can go a long time now with synthetic oil. But are they rated 25? Easy, yeah.